blockchain technology, history of blockchain, and the how blockchain it works. So blockchain technologies, originally blockchain is growing list of records called blocks that are linked using cryptography. Each block contains a cryptography hash of the previous block, a timestamp, and transaction data, generally represented as a Merkle tree. A blockchain is, in the simplest term, time-stamped series of immutable records of data that is managed by a cluster of computers not owned by any single entity. Each of these blocks of data is secured and bound to each other using cryptography principles or chain. Blocks on the blockchain are made up of digital piece of information. Specifically, they have three parts. Blocks store information about transaction like data, date, time, and dollar amount of your most recent purchase from Amazon. Maybe Amazon is used for illustration of purchase. Second one, blocks store information about who is participating in the transaction. A block for your splurge purchase from Amazon would record your name along with Amazon.com. And instead of using your actual name, your purchase recorded without any identifying information using a unique digital signatures or sort of like username. The third one, blocks store information that distinguishes them from other blocks, much like you and I have name to distinguish us from one another. Each block stores a unique code called a hash that allows us to tell it apart from every other blocks. Let's say you made your splurge purchase on Amazon, but while it is in transit, you decide you just cannot resist and need a second one. Even though the detail of your new transaction will look nearly identical to your earlier purchase, we can still tell the blocks apart because of their unique codes. When blockchain stores a new data, it is added to the blockchain. Blockchain, as its name suggests, consists of multiple blocks strung together in order of block to be added to the blockchains. However, four things must happen. A transaction must occur. Let's continue with example your impulsive Amazon purchase discussed in the introduction part of blockchain technologies. After hastily clicking through the multiple checkout prompt, you go against your better judgment and make a purchase. The second one is that transaction must be verified. After making that purchase, your transaction must be verified with other public records of information like the Security Exchange Commission's Wikipedia or local library. There is someone in charge of vetting new data entries. With blockchain, however, that job is left up to a network of computers. This network is often consists of thousands. In the case of Bitcoin, about 5 million computers spread across the globe. When you make a purchase from Amazon, that network of computer rushes to check that your transaction happened in the way you said it did. That is, they confirm that detail of the purchase, including the transactions, time, dollar amount, and participants. More on how this happens in a second. That transaction must be stored in a block. After your transaction has been verified as accurate, it gets a green light. The transaction, dollar amount, your digital signatures, Amazon digital signatures are all stored in a block. There are transactions will likely join hundreds or thousands of others like it. Fourth, that block must be given a hash, not unlike angle earning. It is when once all of the block's transactions have been verified, it must be given a unique identifying code called a hash. The block is also given the hash of the most recent block added to the blockchain. Once hashed, the block can be added to the blockchains. By designing a blockchain, it resists modification of that data. It is an open, distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. For use as a distributed ledgers, a blockchain is typically managed by peer-to-peer network collectively adhering to protocol for inter-node communications and validating new blocks. Once recorded, the data in a given block cannot be altered retroactive without the alteration of all subsequent blocks, which requires the consensus of network majority. Although blockchain records are not unalterable, blockchains may be considered secure by designing exemplify a distributed computing system. The blockchain network has no central authority. These very definitions of the democratized systems. Since it is shared and immutable ledgers, the information in it is open for anyone and everyone to see. Hence, anything that is built on the blockchain is by its very nature transparent, and everyone involved is accountable for their actions. History of blockchain. The first work on cryptographically secured chain of block was described in 1991 by Stars Haber and Scott Stornad. They wanted to implement a system where documents timestamps could not be tampered with. In 1992, Bayer, Haber, and Stornad incorporated Merkle tree to the design, which improves its efficiency by allowing several documents certificates to be called into one block. The first blockchain was conceptualized by a person or group of people known as Satoshi. Nakamoto in 2018. Nakamoto improved the design in an important way using the cache like the method to add block to the chain without requiring them to be signed by a trusted party. The design was implemented the following year by Nakamoto as a core component of the cryptocurrency Bitcoin, where it served as the public ledger for all transactions on the network. In August 2040, the Bitcoin blockchain file size containing records of all transactions that are occurring on the network reached 20 gigabytes. In January 2050, the size had grown to almost 30 GB. And from January 2016 to January 2017, the Bitcoin blockchain grew from 50 GB to 100 GB in size. The words block and the chain were used separately in Satoshi Nakamoto's original paper, but were eventually popularized as a single word blockchain by 2016. Blockchain explained. A Blockchain carries no transaction cost. An infrastructure cost, yes, but no transaction cost. The blockchain is simply yet ingenious way of passing information from A to B in a fully automated and safe manner. One party to transaction initiates the process by creating a block. This block is verified by thousands, perhaps millions of computers distributed around the net. The verified block is added to the chain, which is stored across the net, creating not just a unique record, but a unique record with a unique history. Falsifying a single record would mean falsifying the entire chain in millions of instances. That is virtually impossible. Bitcoin uses this model for monetary transaction, but it can be deployed in many other ways. Think of railway company. We buy ticket on an application or the web. The credit card company takes a cut for processing the transactions. With blockchain, not only can the railway operator save on credit card processing fees, it can move the entire ticketing process to the blockchains. The two parties in the transaction are the railway company and the passengers. The ticket is blocked, which will be added to a ticket blockchains. Just as a monetary transaction on the blockchain is a unique, independent, verifiable, and unfalsifiable records like Bitcoin, so can your ticket be incidentally the final ticket blockchain is also a record of all transactions for, say, a certain train route or even the entire train network, comprising every ticket ever sold, every journey ever taken. But the key here is this: it is free. Not only can be blockchain transfer and store money, but it can also replace all process and business models that rely on charging a small fee for a transaction or any other transaction between two parties. Blockchain may make selling recorded music portfolio again for artists by cutting out music component and distributed like Apple or Spotify. The music you buy could even be encoded in the blockchain itself, making it a cloud archive for any song purchased. Because the amount charged can be so small, subscriptions and streaming service will become irrelevant. The three pillars of blockchain technologies. The three main properties of blockchain technologies are decentralizations. In a decentralized system, the information is not stored by one single entity. In fact, everyone in the network owns the information. In a decentralized network, if you wanted to interact with your friend, then you can do so directly without going through a third party. That was the main ideology behind Bitcoin. You and only you alone are in charge of your money. You can send your money to anyone you want without having to go through a bank. Centralized system of code authority that dictates the truth to other participants in the network. Only privileged users and institutions can access the history of transactions or confirm new transactions. In decentralized systems have no core authority to dictate the truth to other participants in the network. Every participant in the network can access the history of transaction or confirm new transactions. The second one is transparency. One of the most interesting and misunderstood concepts in blockchain technology is transparency. Some people say that blockchain gives you privacy, while some say that it is transparent. Why do you think that happens? A person's identity is hidden via a complex cryptography and represented only by their public address. So if you were to look up a person's transaction history, you will not see Bob sent 1 Bitcoin, and instead you will see hash numbers. So while the person's real identity is secure, you will still see all the transactions that were done by their public address. This level of transparency has never existed before within a financial system. It adds that extra and much needed level of accountability which is required by some of these biggest institutions. The third one is immutability. Immutability in the context of blockchain means that once something has been entered into the blockchains, it cannot be tampered with. The reason why the blockchain gets this property is that of the cryptography hash functions. In simple terms, hashing means taking an input string of any length and giving out an output of fixed length. In the context of cryptocurrency, like Bitcoin, the transactions are taken as input and run through hashing algorithms. Bitcoin uses hash number which gives an output of fixed length. Let's see how the hashing process works. We are going to put in the certain input. For exercising, we are going to use the secure hashing algorithm. As you can see in the case of hash 1256, no matter how big or small your input is, the output will always have a fixed 256 bits length. This becomes critical when you are dealing with huge amount of data and the transaction. So basically, instead of remembering the input data, which could be huge, you can just remember the hash and keep track. How blockchain works. Picture a spreadsheet that is replicated 1,000 times across the network of computers. Then imagine that this network is designed to regularly update this spreadsheet, and you have a basic understanding of a blockchain. Information held on blockchain exists as a shared and a continually reconciled database. This is why of using the network that has obviously benefits. The blockchain database is not stored in any single location, meaning the records it keeps are truly public and easily verifiable. No centralized version of this information exists for hackers to corrupt, hosted by millions of computers simultaneously. It is data is accessible to anyone on the internet. To go in deeper with Google Spreadsheet Analog, read the following scenario. The traditional way of sharing document with collaboration is to send Microsoft document to another receiver and ask them to make revision to it. The problem with that scenario is that you need to wait until receiving a return copy before you can see or make other changes, because you are locked out of editing it until the other person is done with it. That's how database works today. Two owners cannot be messing with the same record at once. That is how bank maintains money balances and transfer. They briefly lock access or decrease the balance while they make a transfer, then update the other side. They reopen access or update again with Google Docs or Google Sheet. Both parts have access to the same document at the same time, and the single version of that document is always visible to both of them. It is like sharing a ledger, but it is a shared document. The distributed part comes into play when sharing involves a number of people. Imagine the number of legal documents that should be used that way, and instead of passing them to each other, losing track of version and not being synchronized with other version. Why cannot all business documents become shared instead of transferred back and forth? So many types of legal contract would be ideal for that kind of workflow. You don't need a blockchain to share document, but the shared document analogy is a powerful one. The reason why blockchain has gained so much admiration is that it is not owned by a single entity, hence it is decentralized. The data is cryptographically stored inside. The blockchain is immutable, so no one can tamper with the data that is inside the blockchain. The blockchain is transparent, so one can track the data if they want to. So, why do people use a peer-to-peer network? One of the main uses of peer-to-peer network is file sharing, also called torrenting. If you are to use client-server models for downloading, then it is usually extremely slow and entirely dependent on the health of the servers. Plus, as we said, it is prone to sponsorship. However, in peer-to-peer systems there is no central authority, and hence if even one of the peers in the network goes out of that race, you still have more peers to download from. Plus, it is not subject to the idealistic standard of central systems. Comparison to between traditional centralized downloading and decentralized peer-to-peer. That the traditional centralized downloaders, central web servers, the slow single point failures, high bandwidth usage for servers. Decentralized peer-to-peer downloading is fast, no single point of failures. All downloaders are also uploaders. Thank you. This is all blockchain.